this last distance formula problem. So we've gone through like three of them where I've used a full formula and I've gone to, as painstakingly as I could, trying to show you like where the x2, x1s, y2s, and y1s come from. So this last one I want to show you kind of maybe a little shortcut, because hopefully at this point you're experienced enough to understand when you see like an x2 minus x1, all that's telling you is like the change in x. Okay, so if you kind of look at this last example, I'm going to go up here. Um, we did x2 minus x1, which means we eventually took 6 and we subtracted off a negative 8, and we got a 14 as a result. Well, if you think about 6 and negative 8, those numbers are 14 apart. If you think of like a number line, if you're going from 6 to negative 8, you'd have to go like 2, 0 first, which is 6 values down, and then go down 8 more values to get to negative 8, which is a total of 14 values. Same is true true of the y's. And so, yeah, you did make this calculation of y2 minus y1. Well, y2 is 4, y1 is 7. Well, those are just 3 apart. And if you look, that's more or less what you ended up with in the formula, was something that was basically 3 apart. Yeah, it's negative 3, but that negative ended up having no effect on the problem because you're squaring it anyway. And so the reason I'm bringing this up is because if we kind of accept like this subtraction problem doesn't do anything more than tell you like the change in x or the change in y, then I don't think we actually have to do that calculation if we have numbers that we can just look at and reason or count how far apart they are. Let me give you a sense of what I'm talking about. And so if you, again, let's go back to the distance formula, but I'm going to write it a slightly different way. I'm going to write this as change in x, okay, which is nothing more than what, I'm sorry, that's what that delta means. It's the same thing as change in x, and we'll square that. And then we'll have the change in y, and I'll square that too. And so this change in x and change in y is the same thing as calculating the difference. And again, if we kind of accept like that's all the distance formula is, we can actually get these numbers pretty fast. Let me demonstrate. So we have change in x here. Well, the x's start at 3 and at 12. That's just 9 pieces away. And so the change in x, the x2 minus x1, will more or less give us 9. We can do the same things with y. And so the y starts at 5, ends at 2. Well, if we go from 5 to 2, you've basically changed 3 values. Negative 3 if you want to be technical, but in the end, just 3 values. So instead of like writing all those points one by one, if you realize like all that's doing is trying to help you find the value and change in x, we can just fast forward. And so in this case, it'd be 81 plus 9, which is the same thing as the square root of 90. Going to my calculator, the square root of 90 in this case is just going to be, let's see, approximately 9.487. And you can see, compared to the last couple examples, how much faster this technique is. Now, it is confusing if you're not quite sure what I was talking about when I said like x1, x2 minus x1 is just change in x and y. But if you've been kind of paying really close attention to like the rhythm and how it's related to the Pythagorean theorem, like this is not a huge leap. And so we have like 4 problems here with the distance formula. It is a little more complicated, but in the end, it's a lot more useful because it's generalized. It's useful as long as you have 2 endpoints, whereas like the Pythagorean theorem, you're really going to have a good, strong visual. Okay? So either way, those are the distance formula examples. Hope that helped. If not, you can certainly watch this again, watch a second time. The comprehension usually goes up. But at least it should give you some really specific questions you can ask me in class. Okay? So that's it. That's the end of the level 1 notes. Good luck with the rest of the level 1 problems.